Physics Class 8. Myself, Zainab Bahari. Today, we are going to continue with chapter number 7, Sound. Part 2, Characteristics of Sound, Monotone Sound, and the numericals based on the chapter Sound. So here we begin with revision of last week. As we know that sound travels in the form of waves, as well as sound requires medium to propagate. Sound travels quickly through the solid mediums, then the liquid and gaseous mediums. Sound travels by the means of two types of waves, transverse waves and longitudinal waves. In the transverse waves, particles of medium vibrates perpendicular to the direction of the propagation of wave, while in the longitudinal waves, particles of medium vibrates parallel to the propagation of sound wave. You can observe here in this picture we also have studied some definitions related to the sound, like period of oscillation, frequency, and amplitude. We also discussed their formulae and units. Let us begin with characteristics of sound. Characteristics of sound. Sound can be characterized by its basic three characters. Amplitude, which is related to loudness. Frequency, which is related to pitch. And third is waveform, which is related to quality of sound, or we can say timbre of sound. Frequency of sound wave is nothing but the number of back and forth movement of particles of the medium per unit time. In other words, frequency is the number of waves reaching to the listener every second. Frequency is measured in hertz or cycle per seconds. Capacity of human ear to hear the sound frequency between 20 Hz to 20,000 Hz. Frequency or the wave does not change regardless to the medium. The perception of frequency is commonly referred to as pitch, while a sound with higher frequency is laid to have higher pitch. On the other hand, sound with lower frequency had lower pitch. The pitch is also referred as shrillness of sound. Amplitude of sound. Amplitude of the sound wave is the height between the topmost part of the wave, that is peak, and the bottommost part, throat. When the amplitude is high, the sound will be louder. The loudness of sound is proportional to the square of the amplitude and is measured in the decibels, dB. We are going to discuss in detail about amplitude of the sound.
Stretch the rubber band, pluck it gently, and listen to the sound. Next, pluck the stretched rubber band strongly and listen to the sound. Isn't the sound louder this time? When you pluck the rubber band gently, the force applied is small, and this produces vibrations with small amplitude. That is, the rubber band is displaced only a short distance from its original position. Small amplitude results in a sound with low volume. When you pluck the rubber band strongly, the force applied is greater, and this produces vibrations with large amplitude. That is, the rubber band is displaced a greater distance from its original position. Large amplitude results in a sound with high volume.
What do you understand by amplitude? Loudness of the sound is nothing but the characteristic of sound by virtue of which a loud sound can be distinguished from the faint sound. Both have the same frequency and the same waveform. As we have seen in the stretched rubber band, if it is plucked hardly, it produces loud sound, and when it is plucked gently, it produces faint sound. One more example you can observe here. This is xylophone. I'm going to struck the xylophone with the stick. Listen the sound. Now the same xylophone I'm going to struck with little large force. When it is hammered strongly, it produces loud sound. When it is hammered gently, it produces faint sound. Similarly, if you strike the drum gently, it produces faint sound. And if you strike drum loudly, it produces louder sound. So here, loudness gets affected by few factors. In the next session, we are going to study about the factors affecting loudness of the sound.
Come, let us observe what are the factors that affects loudness of sound.
If you strike a tuning fork with rubber pad, you will hear a low sound. But if you strike hard, a loud sound is heard. Loudness is the characteristics of sound that can be distinguished from the faint sound, with both having same frequency and same waveform. Loudness depends on the amplitude of vibrations. Greater the amplitude of vibrations, louder is the sound produced. Following are the factors that affect the loudness of the sound. They are the amplitude of wave, the distance of source of sound, the surface area of the vibrating body, and the sensitivity of the listener. Observe the scenario. What do you understand from this? A feeble sound is heard and balls moves up to a small height. This shows that the amplitude of vibration is small. Now observe the scenario. The drum produces a louder sound and balls jump up to a greater height. This shows that the amplitude of vibration has increased. When a body vibrates with greater amplitude, it sends greater amount of energy, and hence the energy received by the eardrum is larger, thereby the sound heard is louder.
In this activity, we observe
The source was struck gently. The balls which were kept on it jumped at little height. This proves the first case amplitude of vibration was less. and it produces faint sound. While on the second case, the balls jumped little more height, which proved the amplitude of sound was larger and produced louder sound than that of the previous one.
Observe the sound produced in this scenario. What do you understand by this? Loudness depends on the distance between the listener and the source of sound. If the source of sound is close to us, we can hear louder sound. If the source of sound is far away from us, we can hear only feeble sound.
Here, in the second case, we can understand the second factor which is affecting the loudness of sound. That is distance between the listener and the source of sound. If the listener is close to the source of sound, he or she hears it quite louder. But if the listener moves away from the source of sound, the sound becomes low or faint. And eventually, the sound becomes very slow as the listener goes away and away. Finally, it becomes inaudible. Thus, we can say that the closer the source of sound, louder the sound we can hear, and farther the source of sound, feeble the sound we can hear. Let us move to the next factor.
As we know, broad drum produces loud sound and narrow drum produces faint sound.
How this happens? A large vibrating area sends forth greater amount of energy. So the amplitude of vibration is larger. As a result, the sound produced is louder. While in the second drum, which is having lesser area, produces the less amount of energy and less amount of sound amplitude, which result in the feeble or fainter sound.
Observe this. The sound produced by the big drum is louder than that produced by the small drum. Loudness depends on the surface area of the body. Hence, larger the surface area of the vibrating body, louder is the sound heard.
The next factor is sensitivity of the ears of listener. Loudness of sound depends on the sensitivity of the ear of listener. A given sound may appear loud to the listener but not so loud to the another listener. To a deaf listener, a louder sound will appear feeble. Always remember the relationship between the loudness and amplitude. The loudness of sound is directly proportional to the square of the amplitude of wave. It implies that on doubling the amplitude of waves, the loudness becomes square of it. That is, becomes 4 times larger. If the amplitude is 2, then loudness will become more by 4 times. And if the amplitude of wave is tripled, then loudness will become 9 times. So from this we can conclude loudness is directly proportional to the square of amplitude. You can observe here in these figures.
Let us have a quick recap what we discussed.
Loudness of the sound depends on the sensitivity of the ears of the listener. A normal sound may appear to be louder to a listener than a faint sound to a deaf listener. It depends on the sensitivity of the ears of the listener. Hence, loudness depends on the square of amplitude. Amplitude depends on the square of square of amplitude. Amplitude depends on the square of square of amplitude. but not so loud to the other listener. The loudness of sound is directly proportional to the square of amplitude of wave. It means on doubling the amplitude of wave, the loudness becomes 4 times. From the graph A and B, we find the wave frequencies are same, but amplitude is different with 2 cm and 3 cm respectively. Hence, we infer that the loudness of wave is directly proportional to the square of amplitude. Loudness is expressed by the unit called decibel. Note, 1 decibel equals to 1/10 of bell, where the bell is the unit of level of loudness named after Alexander Graham Bell. The level of sound for normal hearing ranges from 0 decibel to 80 decibel. A constant hearing of the sound 120 decibel causes headache and permanent ear damage. Following table gives some of the loudness of the sound coming from various sources.
Now let us turn to the next. What is pitch? How does it change in the different musical instrument? Look here, what is happening? Frequency of sound of shouting women is shriller than that of the shouting man. Pitch. Here we are going to discuss about the pitch. Pitch is the characteristic of sound that differentiate shrill sound from a flat sound. It depends on the number of vibrations per second. Pitch refers only to the musical sound, and each musical note has a definite pitch. If the pitch is low, then the sound is flat, and if the pitch is high, sound is shrill. Let us observe the concept of pitch with this animation.
In a television, bass and treble refer to low and high pitch respectively. Pitch of a note depends on its frequency. 2 notes A and B produced on the same instrument with same amplitude of 2 centimeters. The time period for the waves A and B is 1 second and 0.5 second respectively. Therefore, the frequency f of wave A is equal to 1 by 1 second, which is equal to 1 wave per second. But the frequency of wave B, f, is equal to 1 by 0.5 second, which is equal to 2 waves per second. On comparing the frequencies, wave A is of low pitch, while wave B is of high pitch, as pitch is determined by frequency of sound. The 2 notes have same amplitude but different pitch. This is due to the fact that the 2 waves differ in their frequencies. In musical instruments, we can change the pitch of sound by changing the length of the vibrating air column. Let's see the ways of changing the pitch in different musical instruments. Instruments like piano, guitar, and violin have several strings of different thickness and tension. The frequency of vibrations depends on the thickness and tension of the string. High pitch is obtained by vibrating the string under high tension or vibrating thin strings. The pitch of sound in the string instruments also depends on the place where it is plucked. If a string stretched between its ends is plucked more closely to the one fixed end, higher is the pitch of the sound is produced. The musical instruments like shawm and xylophone, a lower note of sound is obtained by closing some more holes so that the length of the vibrating column increases. Hence, the pitch of the sound decreases. On the other hand, if the holes are opened, it reduces the length of the vibrating air column so that the pitch of the sound increases. Instruments like dholak, tabla and drum has a membrane which is stretched by means of strings. The pitch of sound depends on the size and tension of the membrane. If the membrane is thin and highly tightened, it produces higher pitch of sound than the thicker one. If we need to increase the shrillness of sound, the instrument of small membrane is taken and its strings are stretched and tightened.
Let us observe the activity.
In this activity, we took some glasses of the same size and we poured different amount of water in each of the glass. In the first one it is less, in the second one it is little more, and we kept on rising the water level in each glass. Come, let us observe the difference in the pitch of the sound produced by each of the glass. Here we found sound produced in the sixth glass is with the low pitch, that is flat sound, and in that of the first glass it is with high pitch, that is the shrill sound. Hope you understand. Let's move to the next topic.
How can we distinguish one sound from the other through its sound quality? Yes, you're right. It is depending on the timbre of sound, or we can say waveform of the sound produced by different objects. Let us observe through this video.
When you are at a music concert, you can hear the sounds produced by different instruments. Each of these instruments sound differently. However, you can still differentiate between the sounds without looking at the instruments. So, how does your brain distinguish between different sounds? Well, it's the quality of the sound that helps you do so. Quality or timbre or waveform is a peculiar feature that differentiates two sounds of the same pitch and loudness. Any sound that is produced by a vibrating body has two or more waveforms of different frequencies. These waveforms are different for different sources of sound, even if their loudness and pitch are same. Due to this, it is easier for us to recognize the source or vibrating body without looking at it. For instance, when you listen to the audio recording of a well-known actor, you can easily recognize his voice without watching him on the TV screen. Did you know how this is possible? Well, that's because the vibrations produced by a person's vocal cords have a characteristic waveform that is different for different people. So, the different waveforms from different sound sources help us to distinguish and recognize sounds. Shown on the screen are the waveforms of sound produced by a tuning fork and a piano. Both have the same pitch, same frequency and loudness. However, they have different waveforms using which we can distinguish between their sounds. The same concept is applicable when we distinguish between the sound played on a flute and a guitar. The guitar has more notes while the flute has fewer notes. As shown here, the difference in the waveforms of tuning fork, flute, guitar and human voice helps you distinguish between these sounds. Note that a tuning fork is the only source body which produces sound of single frequency. This sound of single frequency is called monotone.
A tuning fork is the only sound producing object which is producing the single frequency sound. In this figure, you can note the sound waves which are produced by the tuning fork are of the same, while here they differs from each other. So note down the definition of monotone sound. Keep in note, different tuning forks have different frequencies, and when they struck with a rubber pad, their prongs starts to vibrate with different frequency and produces the sound of different frequency. For example, the tuning fork of frequency 256 per second, 288 waves per second, 320 waves per second, 384 waves per second, 480 waves per second, and 512 waves per second are available. Let us move to the numericals given in the exercise of your lesson. Here question is, two waves of the same pitch have amplitudes in ratio of 1:3. What will be the ratio of their loudness? And second thing of that of pitch. So as we know, loudness is directly proportional to the square of amplitude. Therefore, ratio of loudness can be calculated as loudness of the first object upon loudness of the second object. Here, the amplitude value of the first object is 1 and amplitude value of that of second object is 3. So 1 square upon 3 square, that is 1 upon 9. So the two waves of the same pitch with the ratio of 1:3 amplitude, their loudness will be also in the ratio with 1:9. While in case of pitch, if the two waves of the same pitch are there, then pitch of the first wave upon pitch of the second wave. Here, pitch of both the waves is 1:1. So, the ratio also is 1:1. The second example, two waves have frequencies of 256 Hz and 512 Hz, but same amplitude. We have to compare their loudness and pitch. So loudness, we will go first. Amplitude of two waves is the same. Therefore, their loudness will also be same, that is 1:1. And in case of pitch, the frequencies are different, that are 256 Hz and 512 Hz. So, the ratio of frequencies is equal to 256 Hz is to 512 Hz. On reducing this ratio, we will get 1:2. Since it is the ratio of the same quantity, it will not have any unit. The ratio of their pitch will be 1:2. So dear friends, here we complete our chapter 7, sound. Go through the textbook, read all the concepts once again, and write down questions and answers from the textbook exercise in your notebook. Thank you very much. Have a good day.